right, this section is going to go over the using formulas notes. In this section, we're going to look at how to use formulas. So the first thing to look at is a variable. A variable is a quantity that may change within the context of a mathematical problem or experiment. So variables are things that can change. Typically, we use letters to represent variables such as x, y, and z. However, you can also use letters that remind you of the quantity being represented. So, for example, we might use T for time, V for voltage, B for bacteria. Those are examples where we use a letter that reminds us of what we're representing. Evaluating algebraic expression. So that's where we find the value of the expression for the given value of the variable. So we might have something that says like x equals 5. What does this expression equal? So you're just going to replace the x with that number, and you're going to perform the operations to find the value. So a reminder of our order of operations. First thing you want to do in that order is perform operations within the innermost parentheses and work outward. So start from the inside and work out. If the algebraic expression involves a fraction, treat the numerator and the denominator as if they're in parentheses. So do everything on top of the fraction on its own, everything on the bottom of the fraction on its own, and then do that division for the fraction last. After you've done all the parentheses, then you can evaluate any exponents. So if you have something squared to the third power, to the 10th power, whatever, that's when you're going to do the exponents. The third step is to do all of the multiplication and division as it occurs moving from left to right. So this was different than how I learned it. I learned it, you do the multiplication first, then you go through and do all the division. And that's not actually how we want to do it, because multiplication and division are kind of the same thing. They can be treated as the same thing. So you want to do them as you see them moving from left to right. Same with addition and subtraction. I can write subtraction as addition. So we're going to do the addition and the subtraction as it occurs moving from left to right. Those aren't two separate steps anymore, if that's how you had learned it before like I did. So we still have our little please excuse my dear Aunt Sally PEMDAS. You can still use that to remind yourself. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. PEMDAS, please excuse my dear Aunt Sally, or if you have something similar to help you remember that order of operations. So I've got a couple of examples here that we're going to do to evaluate some expressions. I have one that's a little more simple, and then I have a much more complicated one. So the first one we're going to look at, we're going to do 8 plus 6 parentheses x minus 3 quantity squared. And we're going to put in x equals 12. So the first thing I'm going to do is I'm just going to rewrite this expression. Anywhere I see an x, I'm going to replace that with a 12. So 8 plus 6 parentheses, I'm going to replace the x with 12 minus 3 squared. So parentheses first. So anything that's not inside the parentheses, I'm going to rewrite it. So 12 minus 3 is 9. So inside the parentheses, that becomes a 9. And that just looks really weird, so I'm just going to rewrite that. So that becomes 9, and then it's squared. So the next thing we're going to do is the exponents. The only piece here that has the exponent on it is the 9. The 6 is being multiplied by the 9. It's not part of the exponent. If we wanted the 6 to be part of the exponent, it would have another set of parentheses around it like this, but it doesn't. So the exponent is only on the 9. So 8 plus 6, and then 9 squared. So remember, 9 squared means I'm going to multiply 9 2 times. 9 times 9. If this was 9 to the third power, then I would multiply 9 3 times. So the exponent tells you how many times you're multiplying that number. So 9 times 9 is 81. So this becomes 6 times 81. Then I'm going to look for my multiplication and division. So 8 plus That's not multiplication or division. And then 6 times 81. When we see parentheses next to a number, this 6 parentheses 81 like we have here, that means there's a multiplication here. So 6 times 81 is 486. There's no other multiplication or division, so the last thing to do is that addition, 8 plus 486. So the answer is 494. I'm just going to put a box around it so that I know that that's my answer. You could underline it or circle it or leave it. So the second example here, we have 5 times x plus 15 minus x cubed over 23 plus x minus 2x. And we're going to evaluate that for x minus 3. So this is where up here it said, if the algebraic expression involves a fraction, treat the numerator and denominator as if they were enclosed in parentheses. So this, what I'm going to do is I'm going to imagine that there's parentheses here and here. So I'm going to do what's in the top separate and the bottom, and then that fraction line, which means division, that's the very last thing I'm going to do. So the first thing I need to do is wherever I see an x, I'm going to replace it with a 3 because it says x equals 3. So I'm going to open this big parenthesis that I drew in, and then I have 5 times 3 plus 15, close that first parenthesis, minus 3 to the third power. That's what's up top. Divided by 23 plus 3 minus 2 times 3. The 2 next to the x here means 2 times x, so 2 times 3. And I'm going to go this way. So I'm going to do the top first. So I have 3 plus 15 in parentheses. So 5 times 3 plus 15 is 18 minus 3 cubed. And then I don't have any parentheses in the bottom except for the overall parentheses. So I'm just going to go ahead and rewrite this. This is not the only way that you could do this. You could do this in less steps than I am, but I'm trying to show all of the pieces to this. So then after parentheses, we look for exponents. So there's an exponent in the top. Right here we have 3 cubed. So remember that's going to be 3 times 3 times 3. So 5 times 18 minus 3 times 3 times 3. That's going to give us 27. And then on the bottom, I don't have any parentheses, exponents. So I'm just going to keep rewriting the bottom until I can do something with it. I'm just rewriting this because it looked a little funky. And just keep moving down the line. So I've done exponents, so now I'm going to do the multiplication that I see. So the first one is on top, 5 times 18. Oops. It helps if I type this in my calculator correctly. 5 times 18. That's 90. And then minus 27, that's what I have on top. And then on the bottom, 23 plus 3 minus, and then 2 times 3, which is 6. So I did this multiplication and I did this multiplication. So now we're going to do all the addition and subtraction in these parentheses. 90 minus 27 is 63. 23, oh, I didn't switch colors. Wait, switch colors, switch colors, switch colors. Okay, 63 over 23 plus 3. This becomes 26. And then minus 6. So on the bottom, we end up with 20. So moving from left to right. So then the last thing to do is this division, because these guys have been in parentheses this whole time. So 63 divided by 20, we get our answer of 3.15. It doesn't say how to round this, so I'm going to leave it as 3.15. It would probably say round to the 10th, which would be 3.2. It might say round to the 100th, so that would be 3.15. It didn't say in this example how to round it, so I'm not going to do too much to it. So that is evaluating expressions. Replace the x with the number it says. Use your order of operations to work that down to an answer. So then an equation is when an equal sign is placed between two algebraic expressions. A formula is an equation that uses variables to express a relationship between two or more variables. So an example of this is the formula C equals 5 over 9 times F minus 32. This expresses the relationship between a Fahrenheit temperature F and a Celsius temperature C. We're going to use this formula to find what the temperature in degrees Celsius is given a temperature in degrees Fahrenheit. So if it's 50 degrees Fahrenheit, what is that temperature in Celsius? This formula is going to tell us. So I'm going to take C equals 5 over 9 times 50 minus 32. And then following our order of operations, 5 over 9 times 50 minus 32 is 18. I'm going to come up here. C equals 5 over 9. Oh, nope. That's where I'm at. So I'm going to do 5 over 9 in my calculator first. And when I do this in my calculator, I get a really long string of decimals. I'm going to keep all of those decimals. So what I'm going to do, I get 0.555555555555555. I want to try and keep all of those that I can in my calculator. So I'm just going to hit times 18, and it's going to pull down my previous answer, and then times 18. So then what happens is I get an answer of exactly 10 degrees Celsius. If I didn't do 5 over 9 and get that really long decimal and then times the 18, if I rounded that 0.5555555, it would be like 9.9999999, which would round to 10. But by doing it the way I did it, where I did 5 over 9, and then I hit enter in my calculator, and then I hit the times button, and then I did 18. That gave me exactly 10 from my calculator. So we can do this again with 86 degrees Fahrenheit. So it's the same formula, 5 over 9 But now instead of starting with 50 degrees, we're starting with 86 degrees. So we do the parentheses first. 86 minus 32 is, oh, I'm sorry, my finger zoomed it out a little bit, is 54 degrees. So I'm going to do the same thing. I'm going to do 5 over 9 to get that long 0.555555555, and then I'm going to do times 54. So then I get a Celsius temperature of 30 degrees. Exactly. And there is a formula to convert temperature from Fahrenheit to Celsius. There's also a formula that converts temperatures from Celsius back into Fahrenheit. Another formula we have here is the formula for a football if it's kicked vertically from a height of 4 feet with an initial speed of 60 feet per second. The formula H equals 4 plus 60t minus 16t squared describes the height above the ground h in feet t seconds after it was kicked. So if you have a football, you're holding it 4 feet above the ground, you kick it, this formula will tell you how many feet from the ground it is after t seconds. So 2 seconds after you kick it, how high up in the air is the ball going to be? Well, that's the first question we're going to answer. What was the ball's height 2 seconds after it was kicked? This formula is going to tell us. So H equals, we're looking at 2 seconds, and T stands for the number of seconds after it was kicked. T stands for time. So 4 plus 60 times 2, because that's the number of seconds later, minus 16 times 2 squared. And again, this squared is only on the t, only on the time. It's not on the 16. So we have to do the exponent first, then we multiply it by the 16. If we wanted to multiply, if we wanted the 16t to be squared, it would be in parentheses, but that's not what it is. So only the t is being squared. So I have parentheses here, but I'm using parentheses to show that I'm multiplying. There's nothing happening inside the parentheses. So what I have first is an exponent. So H equals 4 plus 60 times 2 minus 16. 2 squared is 2 times 2, which is 4. And then H equals, I've got some multiplication, so 4 plus 60 times 2 is 120. And then minus, minus 16 times 4 is 64. So I'm going to have to come up here. 4 plus 120 is 124. So this piece is 124. But then I'm going to subtract 64 from that. So H equals 60. And then we want to make sure that we include units on our answers. So we are looking at the height in feet. So after 2 seconds, the ball is 60 feet off the ground. How about 1 second later? What if we look at the height 3 seconds after we kick the ball? That's the same thing, but now instead of looking at 2 seconds, we're looking at 3 seconds. So instead of a 2 for T, I'm going to put in a 3. And same process, 4 plus 60 times 3 minus 16. The exponent comes first. 3 squared is 3 times 3, so that's 9. Then we do our multiplication. 4 plus 60 times 3 is 180, minus 16 times 9 is 144. So then getting to our final answer over here, 4 plus 180 is 184, and then I'm going to subtract off 144, so 40 feet. So 3 seconds later, the ball's now starting to come back down. Maybe it was coming back down after 2 seconds, but it's more back down after 3 seconds. So another formula, using that formula to find the answer to a question. Replacing t for the number of seconds that have passed. And then the last thing in this section is looking at linear equations in one variable. So a linear equation in one variable is an equation that can be written in the form y equals ax plus b. We have two properties of equality. The addition property says that if you have a equals b, then you can add the same number to both sides, c plus a and b plus c, and it doesn't change the value. And the multiplication property is basically the same thing. If a equals b, then c times a is equal to b times c. I can multiply the same number by both sides and it doesn't change the overall value of the equality. And we're going to use both of these facts to solve linear equations. So to solve a linear equation, the steps that we're going to follow is first we're going to simplify the expression by removing any grouping symbols, which are parentheses, and combining like terms. So if you have multiple x's on the same side, you want to try and combine those. If you have constants on the same side, which are terms without x's, you want to combine those. Then you're going to collect all the variable terms on one side and all the constants or numerical terms to the other side. This is done by adding or subtracting the terms from both sides. Then isolate the variable and solve. This is done by using multiplication or division to get the coefficient of the variable, that's the number in front of the variable, equal to 1. And then check the proposed solution in the original equation. So make sure that your answer, if you put it back in for x, that it works. So I have, how many examples? 4 examples that we're going to go through. So the first one says x minus 3 equals 17. So I want to find out what value for x makes this equation true. So to do that, I have minus 3, and this is a constant, this is a constant, and this is a variable. So right now I have two constants, and they're split by the equal sign. So I want to move this minus 3 over to the other side. So I can do that by adding 3 to both sides. Minus 3 and plus 3, that becomes 0. This becomes 0. So what I'm left with is x equals 17 plus 3 is 20. And then I can check this. Is 20 minus 3 17? 20 minus 3 is 17. Is 17 equal to 17? Yes, it is. So x does in fact equal 7 or 20. Second example that I have, x divided by 5 equals 3. So in this case, I have a variable term here, x divided by 5, and I have a constant here. So I don't have to move any constants over, but what I have here, I have x divided by 5, so that's the same as 1/5 times x equals 3. So the coefficient on the x is 1/5. So I need to get rid of that. So I'm going to do that by multiplying both sides by 5. If I multiply this side by 5, these 5s go away and I'm left with just a 1. And then that side becomes 15. So I have x equals 15. And then I can check my answer. So it started out as 15 over 5 equals 3. That's what we want to check. 15 divided by 5 is 3. Does that equal 3? Yes, it does. So this is the answer. These are both one-step equations. Now let's look at a two-step equation. 3x plus 8 equals 50. So here is, a variable term, a constant, and a constant. So the first thing I need to do is I need to move the constants so that they're on the same side, and then the variable needs to be on the other side. So I have plus 8, so I'm going to move the 8 over. Plus 8 can be moved by doing minus 8. So I'm going to get rid of the plus 8 by subtracting 8. So these guys go away, and I'm left with 3x equals 42. Now I have 3x, so the coefficient is 3. I need to make that 1. So to get rid of the 3, I'm going to divide both sides by 3, because 3 divided by 3 would be 1. So these go away, so I'm left with just x. There's only one x, and then 42 divided by 3 is 14. So we're going to check this one. 3 times 14 plus 8 equals 50. Multiplication first. 3 times 14 is 42. 42 plus 8 is 50. Does 50 equal 50? Yes, it does. So this is the answer. If you do this check and this answer is not the same, then your x is wrong and you need to go back and recheck, redo the work and see if you get a different answer. And the last one. This one's much harder. I don't think you're going to see anything quite this hard, but I wanted to include one just in case. So this one you have 2 times x minus 3 plus 5x equals 22. So to solve this one, I'm going to take this 2 and I'm going to do what's called distribution. I'm going to multiply it by the x and the minus 3. So 2x minus 2 times 3 is 6 plus 5x equals 22. So the 2 is, because it's on the outside of these parentheses, it's going to get multiplied by the x and the minus 3. So then one thing we haven't done yet is combine like terms. So notice I have a 2x, my variable terms, I have a 2x and a 5x, and then I have a minus 6 and a 22. Notice those two variable terms are on the same side of the equal sign. So I have 2 x's and 5 x's. Think of those like apples. I have 2 apples and 5 apples. So how many apples do I have together? I have 7. And then minus 6 equals 22. And now this one is just like the previous one that we did. So I have minus 6, so I get rid of a minus 6 by adding 6. So the minus 6 and the plus 6 cancel each other out. So 7x equals 22 plus 6 is 28. And then I have 7x, and I want to have only one x, so I'm going to divide both sides by 7. So now I only have one x on this side. 28 divided by 7 is, I believe, 4, but I'm going to double check that because, there we go, it is. Sometimes the timesing by 7s and dividing by 7s, they just escape me. And then we're going to check this one. Definitely check this one. Go back to the original one. 4 minus 3 plus 5 times 4. Is that going to equal 22? So starting with the parentheses, we have 2 times 4 minus 3 is 1, plus 5 times 4. 2 times 1 is 2, 5 times 4, sorry, I forgot to write this. Okay, 2 times 1 is 2, plus 5 times 4 is 20. Does that equal 22? 20 plus 20, no, words. 2 plus 20 is 22. Does 22 equal 22? It sure does. X equals 4. That last one I would say is harder than anything you're likely to see, but maybe not, but probably. So last thing in this section, if you don't have an equal sign in the problem, do not put an equal sign in there and make it equal to 0. Simplify the expression as much as you can, but don't try and solve it. If you have an equal sign, you can solve it. But don't solve something that doesn't have an equal sign in it. Don't put an equal sign in there if there isn't one. And that's it.